Aloha, this is the last two sections of the book, and I'm going to combine them together and teach you really quickly about permutations and combinations. I'm just going to do a quick introduction. I'm not going to go into too much detail. There's more that you can get into, but I'm just going to skim the surface. So in case you see problems like this in the future, you know how to set it up and solve it. So permutations. They're an arrangement or a list of objects in a specific order. So permutation, the order does matter. Combinations is just a group or a collection of objects where order doesn't matter. So again, order matters for permutation. Combination is just any combination of whatever you want. So for example, for baseball, if I need certain positions like a left field, center field, right field, etc., shortstop, that would be a permutation because they're going in a specific order. But if I just said, hey, any 9 players just go run on the field and grab a position, then that's a combination because the order or the arrangement doesn't matter. Okay, so first, permutations, you'll see a capital P, a number on the left and a number on the right. Why they chose N and R, I'm not sure. But the left number is the total number of objects, and the right number is how many you're going to choose or how many you're going to use. So for example, permutation, if I have 9 baseball players and I have 3 positions I want to fill, left field, right field, and center field, the 9 goes here and the 3 goes there. So out of the 9, I want to choose 3. And what this means is this 9 is like, say, 9 factorial. And 9 factorial is written with an exclamation point. And that just equals to 9 times 8 times 7 times 6 all the way down to 1. Okay, factorial means just that number all the way down to all the numbers down to 1. This number tells you how many you need. So I only need 1, 2, 3. So if you ever see a permutation with 9 here and a 3 here, you just start at 9 factorial and you go 9 times 8 times 7 because you only need 3 of them. And that equals to 504. So what this is saying is there's 504 permutations or different combinations that I can choose to fulfill these 3 positions. Okay, for basketball, if I had 5 basketball players and I need a point guard and a center, I would put a permutation with 5 and a 2 here. So again, it's 5 factorial, but I only need 2 of them. So it's just 5 times 4, which is equal to 20. Okay, so here's another real-world situation. Debit card passwords, you need 4 digits, and they cannot repeat. Find the total number of 4-digit passwords that you can have. Okay, at this point, pause and try it on your own, then come back and check your answer. Okay, what you should have is a 10 on this side because there's 10 different numbers you can choose from 0 through 9. And the number on this side is 4 because we're going to use 4 numbers. Okay, and so I'll use a colored pen so you can see. And so I need 10 factorial, but I only need 4 of them. So it's going to be 10 times 9 times 8 times 7. 10 factorial, 4 numbers. And if you look over here, actually, 9 times 8 times 7 is 504. So this is your 504. Times 10 is 5040. Or you could have multiplied it out. I just was giving a little shortcut there if you noticed. And I noticed you can't really see it that good. So I'm going to rewrite it. 5040. Okay. If you got that, good job. Okay, the next one is combinations. Okay, combinations have a C, and again, this is the total number of objects and how much you're going to arrange, but it's going to give you a C here. And you can see it's a little bit different because for combinations, you're actually going to use the permutations. So you take this number here, if it's 4 and you're choosing 3, you put the permutations on top. So all you did was do the same thing, but put a P instead of a C. And then the number here, this 3, is what you're going to put on the bottom and divide out because you can look it up, but the number of permutations really don't matter in a combination because the order, you're going to have different things all mashed up together. And again, the order didn't matter, so you can divide them out. I know that's not a good explanation, but I'm just trying to keep this quick for you guys. So all you do is go 3 divided by 3, and these cancel. Those cancel. Well, again, this is 4 factorial 3 times, and this is 3 factorial 3 times. So 4 times 3 times 2. 3 times 2 times 1, and that equals to 4. But if you notice, permutations 3 and 3 is just like saying 3 factorial. So instead of putting this big thing here, you can just put this number on the bottom as a factorial. So again, if it's combination with 8 and 5, put that up with a permutation. So you got 8 factorial 5 times, so 8, 7, 6, 5, 4, 5 times. And then put the 5 on the bottom, 5 factorial, so it's 5, 4, 3, 2, 1. And all you do is cross cancel down, 4 and 4. I can take the 3 and the 2 with the 6 out, and then left with 8 times 7, which is 56. Okay. And here's one more quick one. If I have a 10 and a 4, so again, I'm starting at 10 factorial 4 times. So 10 times 9 times 8 times 7. And then the 4 on the bottom, 4 factorial. So I can take the 4 and the 2 to take out the 8. And I can take down the 9 with the 3. And then 3 times 7 is 21. Times 10 is 210. And that's how I got that. Okay. So here's a real life example that you guys can try. There are 20 homona in accelerated math. I need to choose a group of 5 students, any group, to represent KMS at a math contest. How many different combinations can be chosen? Okay, again, pause and try this on your own, and then come back and check your answer. So in this one, I would have a 20 here, and a 5 here, because I'm choosing 5. Oops, I'm sorry, I went wrong colors. Trying to color combo this for you guys. So 20 total. I need to choose 5. And then the 5 factorial goes down here. And the, sorry, should have put it on this side first. Okay, so it should look like that. And I'll go to the black pen so you can see. So it's 20 times 19 times 18 times 17 times 16. 5 times 4 times 3 times 2 times 1. Again, 20 factorial 5 times and break it down. So I can take the 5 and the 4 with the 20. And I can take the 3 and the 2, which is 6, and divide the 18 and change that to a 3. And now you should multiply 19 times 3 times 17 times 16. And you should get 15,504. So there's 15,504 combinations. Oops, can't see it, sorry. To get 5 people out of the 20. Groups of 5 out of 20. Okay, that's the last section of the book. Hope you guys had a good time with algebra, because algebra loves you. Take care, bye.